So, in this video, we were looking at the electron transport chain during the light reactions in photosynthesis. And by doing a role play, I was hoping that you could think back and picture the people and what they were doing and relate it to what happens in the chloroplast in terms of electron transport and production of ATP. So, we had the sun. We had a person who was looking after the light, which represented the sun. At the end of the bench, we had photosystem 2, and she had chlorophyll in her, which would essentially absorb light from the sun. The light comes from other pigments as well, but it gets directed to this chlorophyll, and the electron from the chlorophyll gets excited. So this is the electron. The volleyball represents the electron, and it gets passed along the electron transport chain, which is made up of protein electron carriers that are embedded in the membrane. So we had 3 who were representing electron carriers in the membrane, and the bench represented the membrane itself. So that's the thylakoid membrane. We had a person who represented photosystem 1 that receives is the final electron acceptor, so receives the electron in the end, and another who was representing ATP synthase in the membrane. So, afterwards, we took a look at the diagram again and drew some arrows to kind of represent what was happening, but you should be able to explain what was happening. So basically, the light from the sun is absorbed by chlorophyll in the photosystem 2, other pigments that direct the energy towards that chlorophyll. Its electron gets excited and it's bumped up to a higher energy level. It's passed on to the first electron carrier, which passes it on to the second and on to the third. And with each passing, a little bit of energy is given off. And that little bit of energy can be used to move these hydrogen ions, which were the rocket candies, across the membrane. Okay, so it's establishing a high concentration of hydrogen ions on the other side of the membrane. So, the idea is the electrons are passed along the electron transport chain so that these hydrogens can be moved across the membrane, and there has to be a final electron acceptor. In this case, the electron is going to replenish one that's been excited from photosystem 1. So again, light hits photosystem 1, and when it does, it triggers a couple of steps to happen, and ultimately NADP plus picks up the electron and forms NADPH, which is one of the materials that's required for the Duck reactions. Okay. In the meantime, the hydrogen ions that have been put across the membrane, there's a whole bunch of them over there now, they can pass back through ATP synthase. And the reason it's called ATP synthase is it's an enzyme that can take ADP, or adenosine diphosphate, and phosphate and put them together. So it's an enzyme that catalyzes the reaction, puts them together to form ATP. So the whole purpose of the light reactions is to generate ATP. So you harvest the light energy to generate ATP and NADPH so that they can go and be used in the dark reactions out in the stroma. So that is an explanation of the role play and the light reactions and the electron transport chain.